AD, BC are equal perpendicular to the line segment AB. So we have two lengths which are equal and they are perpendicular to line AB. Show that CD bisects AB. So what does CD bisects AB mean? That we indirectly have to prove that BO is equal to OA. Okay, bisects means bi is 2 cutting into two equal parts. So how can we prove this? Okay, so what we have in front of us is I have a 90 degree and another 90 degree. Then we have this being equal to this. Okay, and I need one more thing, either side or an angle. Obviously I can't take BO is equal to OA. So that eliminates my, see, I have two tools, SAS, ASA, and in future you'll learn about SSS and RHS. So for RHS I need a right angle which I have. Hypotenuse should be equal, which I can't prove now. So this gets eliminated. For SAS I need to have a side. Yes, I have a side. An angle. Yes, an included angle. But one more side that I can't use. Then ASA, I have an angle. Good. I have a side. Good. So this is the included side. So this angle, if I prove that these two are equal, angle C is equal to angle T, I'll be done. How can I do that? That's a bit tricky one. Okay, you guys can think about it. You can pause. So it has to be this only, because SSS requires all the sides to be equal. And it has to be D being equal to C. So somehow we have to prove this. So this is how you eliminate what you have to do. Now, I'm not able to figure out. Let me just write the given. Again, just start writing, keep things in order. Start writing. AD and BC are equal. So let me write that. AD is equal to BC. And are perpendicular to line segment AB. So they are perpendicular to AB. So what can we tell? So AD is perpendicular to AB. This implies angle AD is perpendicular to AB, right? So DAB, okay, let me write it there itself. This implies angle DAB is equal to 90 degree. Then AB is perpendicular to AC. So what can we tell? This implies ABC, angle ABC is equal to 90 degree. Okay, that's good. So what else can we tell? Nothing else as of now. We can't tell anything. So we need to prove CD bisects AB. Okay. So indirectly we need to prove that BO is equal to OA. You can write it in brackets so that you guys can remember what you need to prove. Okay, so I need to talk about this angle C and angle D. So again, whenever I get stuck, I resort to drawing an extra diagram. So just draw. So we have a Z and something like this. So we need to prove this is equal to this. So this looks like, alternative interior angles. For this to be alternative interior angles, we need to prove that this is parallel to this. Can we do that? Yes, we can, right? See here. We have the other, okay, let me actually do this. So now I got it, how to do. Okay, I hope you guys also got it. It's quite simple. See, you have one side, one more side, and the third side. This angle is 90, this angle is 90. This is DA and BC. So if these two are 90, if I happen to extend this, let me actually, I should have done that. I don't know why I didn't do. If I extend this, how does this look? These two are alternative interior angles, is it not? So this angle is equal to this. Okay, so if those two are equal, they are equal to 90. So we have this to be parallel to each other. That's it. Done. If these two are parallel, right, then this angle, that is angle C, will be equal to angle D. Done. Okay, so before you write the proof, try to draw a diagram. It will make things a lot simpler. Okay, so if I prove that these two triangles are congruent, then BO will be equal to OA, and hence we'll be able to prove CD bisects AB. Okay, now the proof. So we'll begin with, as angle DAB is equal to angle ABC, we already written, which is equal to 90. This is given, right? We have written in given, right? So you can write it confidently. Therefore DA is parallel to BC because alternative interior angles are equal. Now with this implies this is BCD and DCDA. This implies angle C is equal to angle D. They are alternative interior angles. Okay, so that is done. Then consider this two triangle 1 and 2. So prove that they are congruent. So in triangle, I think it is ADO and the other one is BCO. We have angle C is equal to angle D. Then we have, actually we had vertically opposite angle. Oh no, we needed included angle, right? Yeah. Then we have DA or ED is equal to BC, and we have DAB, which is equal to angle ABC, which is equal to 90 degree. Okay, so all this has been proved. We're just writing this down, then we'll conclude. Therefore, by ASA, right, angle included side and angle congruency, triangle ADO is congruent to triangle. Here the order is important. The corresponding side of angle of A is B. So B, D is C and O is O. So in place of D it should be C and O is O. Okay, so then we'll write, therefore by CPCT we need to prove that DO is equal to OC. Okay, so you can clearly see from there. This implies, now we can tell what is that we need to prove. CD bisects AB. CD bisects, oh, okay, we need to prove that AD is, no, wait, AO is equal to OC, sorry. AO is equal to BO. This is what we need to prove. This two sides is equal to this two sides, right? Yeah. CD bisects AB at O. Okay, right? Again, scrolling up and down, I made a mistake. If not, it's very clear. So again, I'll repeat. CPCT means the corresponding angles like ADO, BCO, A is equal to B, D is equal to C, and AOD is equal to BOC. And when it comes to side, please have a look at this. AD, okay, let me write it a bit big. Again, try to understand CPCT. So we have AD being equal to BC, DO is equal to CO, and AO is equal to BO. Right? So this is what CP, CT helps you guys with. So that's why you should always write things in order. Okay? So this is your answer.